Up to now I've been looking at the Toy A emulation, but just for some light entertainment, here's an I/O function from the Toy B and Plex emulations, which I'm in the middle of testing. Now it's music related, so it's not normally found in the computers which PlasMa is trying to emulate. And with those machines, the only opportunity for playing tunes, aka mucking about, was to exploit the jump clicks shown earlier and use different length program loops to generate musical notes. You can still do this here, of course, but as I also have an interest in electronic music, PlasMa has two music functions. And one is for MIDI, which is yet to be tested, and the other is a simpler function which plays notes on the built-in speaker normally used for the jump clicks. The function uses the contents of a register to define a music note and its length. Now there are other parameters I'll cover later, but this is enough to make a sound. So first we need the Toy B or Plex emulation. I'll use Toy B, so I'll load microcode 2. Okay, I'll store the note definition into a memory location. Now Toy B has a dedicated I/O function, unlike Toy A, which means there is no special memory address. So we can use FF as normal memory and load our data there. And the note definition comprises the note number and length. Note numbers use the standard MIDI convention where 60 is middle C. I'll use this note, although I've not verified if it really is middle C yet. The 60 is hex 3C, and this goes on the upper 8 bits. So I'll put that on the load switches. C. The note length goes onto the lower 4 bits, which gives 16 possible lengths, and 6 is a quarter note, or crotchet in old money. I want to store this into location FF, so set FF on the memory address switches, and this register, the memory contents register, always shows the contents of this address. So we move the target load light up to this register and press load. Okay, that's the data for this program. Now for the code. I'll set the target load register back to instruction register, IR, as we're going to enter instructions now. So first an instruction to load register 1 with the contents of this FF memory location. So we want 9 for the opcode, 1 for the target register, and FF for the address. Press load and ink, and that's done. Now we want this new I/O function, which is called play note, and that's a 4 for the opcode, 1 for the note register, and 8, 3 for the function. Load and ink. And now a jump back to the start. And Toy B has an unconditional jump instruction, so I'll use that. That's 5, 0, and then the target address is 0, 0. Load and ink. Okay, just confirm the program is correct. Go back to address 0. We've got 9, 1, FF. We've got 4, 1, 8, 3, and 5, 0, 0, 0. Right, this looks okay, so press reset and run. Okay, at the moment we're just hearing the normal jump clicks as before, and this is the default setting when we switch on. But this switch here for the speaker changes the speaker mode. Now if I run it at slower speeds, there's medium, you can see that the loop is going round a lot faster than the notes. This is because the function is ignored if the note is still sounding, so most of the calls are being ignored. Now this is no problem with a simple loop playing just one note, But if you wanted to play a sequence of notes, you need a way of testing when the note is finished. Now I'll show this with a new program, and I'll include some other functions to give real-time control over the note. One of these functions is for reading any 16 bits from the latching switches into a register. And this gives the operator another way of interacting with a program in addition to the hex keypad which we saw last time. So let's use the break switches to control the note in real time. I'll use the top 16 bits, that's these here, to control the note attributes. I'll show what they are later, and use the bottom 16 for the note number and the length, which you've just seen. So we'll start a new program, reset PC. So first an I/O function to read the most significant 16 bits from the break switches into register 0. 4 for the opcode, 0 for the target register, and the function code. Load and ink. Now an instruction to set the note attributes using the contents of this register 0. 4, 0, and the function for this is a D3. Load and ink. And now we're going to read the lower 16 bits into register 1. 4, 1 for the target register, and the function here, I think is that D3, no, 3, 6. Load and ink. Okay, this is where we would normally call the play note function. We've got the note information in register 1, but as mentioned, we should really test if the previous note is still playing. So there's another function which gets the status of the note. And in this example, we'll just use a small do nothing loop if it's not ready, but there's nothing to stop you obeying other instructions while it's waiting. So here's the get note status function, and we'll read the status into register 3. We want 4 for the I/O, 3 for the target register, and the function, which is E3. Load and ink. And the status is 0 if the previous note is finished, or 1 if it hasn't. So we can use a jump if positive instruction to test the status value in register 3. So we want 6 for the opcode for a jump, 3 for the condition register, and the target address is 03. Now if you've been keeping count, that's the address of the previous get status instruction. So we just loop round getting the status. I'll just confirm this using the DEC PC switch. There's address 3, and that's the instruction we want to go back to, the get status. Set PC back to 4 and carry on. Oh, load an ink first. To load the instruction. Right, now we can insert an instruction to play the note. 4 for the opcode, 1 for the source register where the note number and length are held, and the function code, which is 83. Load and ink. And then finally a jump back to the start of the program. 5, 0, 0, 0. Load and ink. Okay, before we start, we want to set the note attributes onto the break switches, because that's where the program is going to read them. Now the attributes are spread across these 16 bits. These 4 bits here are for the gate time, which defines how long the note is on versus how long it's off within the time interval. And a value of 6 gives us a 50-50 note. The next 8 bits are the tempo, and a 0 is 30 beats per minute, which is the slowest it can go. So we just need to add 30 to everything. So if we want 60 beats per minute, say, we need to put 30 on these switches, which is a 1E. This is where you may have to go back and revisit the video on hex numbers. After a while this becomes second nature. It's not quite with me, but I'm a bit rusty. Right, the lower 16 bits, the note number is on these first 8 bits here, and middle C is 3C. And the last 4 bits are for the note duration, and as I said, that gives you 16 possible durations, and 6 happens to be a quarter note, which is our crotchet. So, all set, reset, and run. Okay, if you look at the timer, that's clicking up in seconds, and it does in fact confirm that this is 1 quarter note per second, which in theory should be correct for a tempo of 60 beats per minute, assuming I've got my sums right. I'm sure you'll let me know if I'm not. Alright, let's switch over to the jump click mode and press run. And we'll run at medium speed. And you might be able to see the status of the note coming on and off here. And the clicks now are quite instructive, because the fast clicks are the wait loop, and that pause you get before the next click is the program actually playing the note. So we've got a small loop within a big loop. Okay, full speed. And those are the notes. Okay, let's change a few switches, because we know the program is reading these switches each time before each note. So let's try the gate length, which was these 4 bits here. So we'll have a change that to 2. Okay, that's shorter staccato-like notes. And then we can go up to 15. And that's the longer legato-like notes. Okay, now for the tempo. Let's try doubling the tempo to 120. And that equates to a 5A on here. I'll reset it so the counter, the timer up here starts at 0, then you can check it's the right speed. There we go, we're getting 2 notes every second, which is correct. Okay, let's try the note number, which is this. This is note C, this should be C sharp, and D. Okay, and finally the note length, which are these 4 bits here. This is the smallest, oh no, that's the smallest it would go, a 30-second note, a demi-semi-quaver, and we can go up to 13, I think, 12, 13. That's a dotted double note. Don't forget, we've got the gate time set to 50-50 here, so what you're actually hearing is half the interval. Okay, that's covered quite a lot this time, so apologies for that. But just as a bonus, I'll finish by loading a much longer program, which might prove amusing, especially if you're a film buff. It took 33 minutes and 21 seconds to get right, but don't worry, I'll speed it up with time lapse. So thanks for watching. Okay, there were a couple of mistakes in that, but it's all corrected, so here we go.